Hello and thanks for stopping by. As any of you who've been following along with our BDST project knows from Doug's channel, we've run into distortion problems on the RF section of the BDST, and I was testing and the initial testing, all I was doing was trying to make it the most sensitive, so I got it where on really weak signals there was no distortion. The signal looked fine on the oscilloscope and everything. But, again, it was a case of tunnel vision or whatever. I was only concentrating on the low end, never even thinking about what would happen when it got up to a higher signal. So I've been doing a bunch of testing. Now, this here is the signal that I've been feeding into all of the test circuits we're going to be looking at. It's a little over 4 volts peak to peak, 400, roughly 400 hertz sine wave. Now, this is our current circuit. We're feeding in, we're just looking at the RF circuit. We're feeding into a 1 nanofarad capacitor, going through a 1N5711 diode. One end of that is shunted to ground with a 220 picofarad capacitor, and the other end is the output. And that nice clean sine wave turns into this, which is anything but a sine wave, as you can see. Now, looking at other circuits, Doug took and said, well, how about Heathkit? Theirs seemed to work okay. Well, yeah, with their, somehow it worked or whatever, but this is Heathkit's input circuit through, when you have the probe set to RF, you're going through a 1N34A diode, through a 1 nanofarad capacitor, and out. And using that, this is what the output of that looks like, which again is really anything but a nice clean sine wave. It's a little sharper than the other one is, but still it's nowhere near a sine wave. Now, when I was designing ours, I took and basically copied one from Don over at Restore Old Radio. And there again, now he uses an op amp for the amplifier, so maybe that's what straightens it out. But then I looked at the output, and the output looks just as distorted or whatever. But this was Don's circuit. He went in through a 1N34A in the probe, 220 to ground, and then out through a 1 nanofarad. Well, the only thing I did was move the 1 nanofarad on the other side of the diode. So I mean, it really shouldn't make a difference. And as you can see here, it's just as distorted as ours is. They're basically the same. Now the original circuit, the one from like my original big unit that we were basing all of this on, had an RF input circuit like this. It came in through a 1 nanofarad capacitor, had a 1N34A diode going to ground, and then the top there, the signal part, went over to a voltage divider with a 4K7 to ground and a 22K, for the output. And using that, this is what it is. Now, it's a weaker signal, which is why it's fuzzier on, my little cheap scope or whatever. But as you can see, that's the closest to a sine wave that we've had out of all of these circuits that I've tried so far. But the trouble with using this is that it requires a double pole, double throw switch. Because here, if you take and look, okay, this is that circuit in the audio position. Both parts of the switch are up, so it basically just shorts the one switch to the other switch because we're just feeding the audio straight through. And then when you're down into the RF position, it's fed through this way. But now if you take and try to use, the problem with using a single pole switch here is that, okay, if we put a single pole switch on this side, on the input, only on the input side, well then, when you're feeding an audio signal, the audio signal is going to go up and go through, but then part of that signal is also going to go through those two resistors down to ground. So that's going to take and degrade, to me, degrade the audio signal some. And if we take and put the switch on the other side, then, okay, the audio signal is going to go through the top section there, but then some of it's also going to go through the bottom section there. The capacitor will pass the AC signal, and it's going to go through that 4.7 to ground. So where I'm going to go from here now, I think, is a couple things. A, I'm going to take an experiment with these two single poles diagrams and see exactly how bad it does affect the audio signal compared to the original. And the other thing I'm going to take and play around with is R1 to see whether, using a double pole, double throw, for that nice clean sine wave. If the reason we took and started looking for other circuits is because it was so much weaker. Well, maybe changing R1, I can take and boost that signal up so that it's, it'll still be a nice clean sine wave, but be a stronger signal so there's not such a difference between AF and RF settings. But if we do have to go with the double pole, double throw, I mean, it's really no big deal. Here's a picture of a board that I took and drew up or whatever that will work, and it's the same exact layout as the board we're currently using now. Only down in the lower left there, you can see the voltage divider circuit and stuff, and then up where the toggle switch goes, you can see there's 6 contacts now for the 2 sides of the double pole, double throw. So to me, it's no really big deal to go that way, but if we can take and stay with a single pole, double throw, that's what we're going to take and try to do. So let's just try to take and bring everybody up to date on, what the problem actually is and the things that I'm trying to take and do to take and alleviate it. Anybody have any ideas, please leave them in the comments. Thanks for stopping by and have a nice day.